Okay, so what I'm going to do today for this meeting is give a relatively short demo of a proof of concept of using our code to generate CRDs, validate those manifests against the CRDs, and also to highlight some of the challenges around that because of the complexity of our CRDs versus the kind of like CRDs you get in other situations. And also going to show a short demo of an editor built using kind of some of the same principles to do it. The background of this is that we've had a bit of, we have relatively regular feedback from people who struggle to author workflows in a YAML format because we don't really provide any kind of any plugins for IDEs or so forth that allow you to auto-complete your YAML based on the values that it should have in your IDE. And we know that people use IDEs to edit the YAMLs. They also want to use SDKs to get some of that kind of auto-completion. And so the hypothesis is by providing CRDs with open API specifications that can then be used by people in their editors to validate their YAMLs. That's basically the hypothesis behind this. And the kind of proof of concept, the way to demonstrate this is to obviously do that in the IDE, but also it kind of makes it relatively straightforward to build a better editor inside the user interface as well to kind of reveal that feature. So what I'll do is I'll start by showing the CRDs. I'm actually showing the wrong window, so let's share the right window to do that. There we go. In the code base, you can find the CRDs by looking under manifests, base CRDs. And in this proof of concept, there are 3 sets of CRDs, which are given the name full, minimal, and simple. The minimal one is really just the same CRDs that we currently have in version 2.8. So they come basically with fully lax validation of the CRD. You can submit any data and the controller just has to figure out what that data actually is. Full schema validation is a full set of validations for all elements of the schema with the additional complexity that this creates relatively large files. And if we have a look at this workflows file, you can see that the file itself is 13,000 lines long. So it's a very, very long file. And this is really a reflection of how complicated the Argo workflow schema is compared to a normal schema. And also a reflection of how Kubernetes CRD schemas are not the same as a normal JSON schema. And there are kind of 2 major differences between them. One is the kind of use of a number of kind of Kubernetes attributes, which the Kubernetes API server treats differently. This particular one, preserve unknown fields, is effectively the same as saying this object can be anything at all. And the other one is that the schema that is used by the Kubernetes API server does not allow definitions. So it doesn't allow a schema that can reference other schema. And the challenge around that is we actually reuse a large number of components in our schema. For example, the script and the script template is very similar to the container template, both of which reuse a lot of kind of standard Kubernetes objects. That makes this actually much, much larger than it would be. And we can compare this with the JSON schema, which is generated and saved in assets/schemas. We can look at the workflow schema and we see that this workflow schema, while still very large, is still significantly smaller than the CRD schema. And bear in mind, this is JSON formatted rather than YAML formatted. So even though it's 5,000 lines long, it's probably the equivalent of around 2,500 to 3,000 lines of YAML. So it's around 20% of the size, and that size creates challenges for the OpenAPI server. And the problem I found that is it takes a long time to load the CRD schemas. Running into minutes to load them. So these full schemas are probably not the kind of schemas you want to use for your servers. And so the minimal one provides you with a one that actually is, you know, very safe fallback position, and currently all the code actually uses that, though they're all generated by the same script. And then this simple one that's an intermediary, which is smaller. So this is only 2,000 lines long, so this is potentially usable, whereas the full one is not. What this does is it basically treats any Kubernetes core resource, such as container or so forth. It just treats that as in any object, and it simplifies the schema that way. The theory there being that what you really care about in the schema is the stuff that's workflow specific, and you don't care too much about that. And so I can go into my I can go into my schema here, and I can load this up in IntelliJ. Can you guys see the preferences dialog? I don't think so. Let me share the preferences dialog with you. If that is, I think I can do. Okay, it's preferences dialog. And if you've got the Kubernetes plugged in for IntelliJ, you can go in there and you can add these as either URLs or you can add them there, and it will automatically detect that. I try to get this to work with VS Code because that's very popular. I was unable to do that, but I don't use VS Code on a daily basis. And this then provides you with, you know, you can mouse over a particular part of the schema, and it will tell you about that, and then you can command click, and it will tell you all the different things you can stick in there as well. So if I wanted to kind of do that, that makes it kind of harder for me to kind of make mistakes with you know, the schema, you know, getting it more or less right with the right values. This only provides schema validation. And we know some of the things people would like to do is actually have things like these template values also kind of auto-completed. That's quite difficult to do for obvious reasons, that can't just be done using CRD validation. You'd actually have to go and write a plugin for the ID that was an Argo workflows plugin that did that. Okay, so I want to just now move on to show this in the actual user interface. So the user interface doesn't use the CRD specs. It uses a piece of software called Monaco, which is a Microsoft editor that VS Code uses, and that can be embedded in our application because it's JavaScript, and we can use that. And so here's the editor. And so this is not very polished, so I apologize for this. This editor replaces the existing resource editor. And by default, it shows you in JSON rather than YAML, but it kind of provides the same kind of auto-completion. So if I hover over the container, it'll tell me about what the container is. If I do command click, it will tell me that I need to type in that, and it tells me as an integer if it's a value. It'll also like highlight the fact that this is, you know, invalid JSON, where currently we don't provide that. These are all kind of out of the box with it. That's for JSON. Unfortunately, for YAML, the kind of same sophistication doesn't actually exist in the YAML editor. Only really for the JSON editor does JSON schema support kind of work particularly well. So it has some idea of, you know, the words that we could use there. But you can see that it's suggesting the word awesome, which obviously isn't a valid, valid value for YAML here as well. I can then just submit this specification, or I can upload a more complicated one. Submit that. And if I go back to JSON schema, you'll see it highlights it as well. Again, doesn't highlight some other kind of stuff, such as, for example, coin flip. If I were to type that in incorrectly, because I call it coin, no, let's not use that one. It's coin flap. And if I submit that, that will fail, but it won't fail syntactic validation. So that will tell me the coin flip is undefined, it's not valid, and I have to then reload and start again because I've made such a critical typographical error. I can do that, and I'll just run the workflow. So that's basically the end of the demo. I'm just going to stop here at this point and just see if people have got any questions or thoughts on this they'd like to share now. Okay, I'll take that as a no. At that point, so I'll stop sharing, and I'm just going to stop the recording at the moment. Okay, stop the recording.